Polar coordinates and Cartesian coordinates, they're both talking about identifying points in space. So you could have this point, maybe it's 2, 3 in Cartesian coordinates, which means 2 on the x-axis and 3 on the y-axis. Sometimes those are called rectangular coordinates because we're forming a bunch of rectangles. That's one way of identifying that point. We could identify that point another way. We could identify that point by its distance from the origin, so we call that r, and then we could also identify that point by the angle of rotation that's made to get to that point. We call that theta. So if you know a theta and an r for a point, that can tell you the same thing as 2, 3 in this instance. So polar coordinates are other ways of identifying points using just the radius, the distance from the point to the center, and using an angle. Okay. So this is your radius, and this is your angle theta. Students ask, like, why do we do this in the first place? You can create a lot of unique functions with polar coordinates, and you can also solve problems in mathematics by converting things to polar coordinates and then using properties of polar coordinates. Like one, I believe, is find the showing that the area under the curve of the normal distribution. You probably don't care about this, but finding the area under the curve of the normal distribution in statistics, we can switch that to polar coordinates, and it makes it much more easier to solve with calculus. But anyway, we have the point 10, 10 comma pi in polar coordinates. That means it's halfway around the circle, right? Because pi is 180 degrees. Pi in radians is 180 degrees. And then the radius is 10, so that means it's 10 units away from the origin. So here we are at negative 10. Okay, and I put in negative 10 on the x-axis because we're converting it to Cartesian coordinates, the x and y coordinates we're used to seeing. So let me just go through that again. I kind of went through it too fast. Let's start with the angle theta. The angle theta in this case is pi. That's 180 degrees. So initial side to terminal side, we end up here. Now it could be there. We haven't identified r yet. An angle of pi could be here. An angle of pi could be here. So the location we go to is at negative 10 on the x-axis because r is 10. We are 10 units away from the origin. And I put a negative sign there, again, just because we're on the left side. This is negative 1, this is negative 2, etc., etc. So negative 10 comma 0 is this point in Cartesian coordinates.